PCR Puttur, Karnataka, Stanford University, and University of California. I am your moderator for today's session, Nandini Sharma, and it is my honor and privilege to welcome you all for the today's session. We are incredibly fortunate to have with us a visionary leader and a renowned scientist in the field of crop science and genetics, Professor Dr. Ephraim Hebriamana. Dr. Ephraim is an internationally acclaimed expert with over 3 decades of experience in crop science, genetics, and plant breeding, particularly focusing on sorghum, a vital crop for food security and income generation for smallholder farmers worldwide. As the principal scientist of sorghum breeding research at ICRISAT's global headquarters here in India, his contribution have been pivotal in driving productivity and sustainability in agriculture, not just in Asia, but globally. His work seamlessly integrates cutting edge technologies such as agroecological and genomic modeling, big data analytics, and phenomics. Through these innovations, he has redefined crop improvement strategies, ensuring they are not only resilient and cost effective, but also environmentally sustainable and biodiversity friendly. Dr. Ephraim's outstanding achievements extend beyond research. He served as a professor at the University of Agriculture Sciences, Raipur, India, where he inspires and mentors the next generation of agriculture scientists. His groundbreaking contributions have earned him recognition as an inventor by the European Commission, and he was a finalist for the 2019 European Data Science and Artificial Intelligence Awards. Today, we have the incredible opportunity to learn from his vast expertise and innovative approaches to addressing some of the most pressing challenges in global agriculture. The topic for the today's session is perennial arable crop transformative transition, potential for resilient agriculture. We are confident that his insights will inspire us to reimagine possibilities in the field and drive impactful solutions. Let us warmly welcome Professor Dr. Ephraim to take the stage and enlighten us with his knowledge and vision. Over to you. The session is yours, sir. Thank you. Sir, you are not audible to us.
Yes, sir, you are not audible, sir.
Now you have unmuted it. You can speak now, sir. I think your mic isn't working.
Rohit,
Sir, I
please
think
suggest.
yeah, sir, I think headphone is not working. Can you just like do without headphones, sir, please?
Rejoining will be the solution or not?
Maybe, sir.
Then please suggest.
Yes, sir. Sir, can you just like rejoin the Zoom, please? Left the meeting, then please rejoin, sir. I will make you go. Sir, you're not audible still.
Can you hear me now?
Yeah, it's working, sir. It's working.
Hello?
Yes, sir. It's working, sir.
Sir, I'm getting your voice. You may proceed, sir.
Can you hear me?
Yes, sir.
Yes, sir, we
Clear.
can hear you.
We can hear you, sir.
Okay, okay. I can be now audible, right? Hello?
Yes, sir. Please
Yes, sir,
share
you
your
are
screen, sir.
completely audible.
Okay, now I understood the problem. I have to change the
Headphones. It must
I
be the
have to change
headphones.
the
Sir, if any issue, then please share our PPT with us. Our moderator will present at his side.
okay, one moment, please.
Yes, please.
Okay,
Ah.
so I think
You may share through WhatsApp.
now you can see the presentation.
Yes.
Yes,
It's
sir.
visible.
Okay. I was obliged to change the microphone because the microphone is not compatible.
Okay.
So now let me go into presentation mode.
Sir, please do it in PPT mode.
Yeah, like this one. Okay, yeah, I'm sure that audio will be a bit different. I apologize because there was a compatibility between the microphone and the PC as I'm traveling now in Kolkata right now. So thank you so much for the introduction, and I'm sorry for this glitch. So I will try to go to walk you through this presentation I prepared for you. My intention was just not to present breeding topics as usual, but try to discuss with you out of box because there is an increasing interest in the perennial arable crops due to the necessity to respond to the climate change challenges. So at ICRISAT, we have started working on this issue. And as a head of sorghum breeding at ICRISAT headquarters and supporting Africa, I have myself initiated the work on perennial sorghum as opposed to annual sorghum to see how best we can respond to climate change challenges. So to start, I will present a few premises here, starting by the fact that it is now real that drought conditions are being a big issue worldwide, and the severe manifestations are observed particularly in Africa and in South Asia, India being included. And not only drought, but there is increasing evidence of occurrence of heat and drought conditions all over the world, and particularly in Africa and South Asia, and as I said, always India also being included. The most concerning aspect all of this is that the map of heat and drought is overlapping with the map of hunger, meaning that the drought and the heat might be contributing to this important problem of undernourishment in Africa and South Asia, and indeed in areas where dryland conditions are manifested, but particularly in smallholder farmers of developing countries like in Africa and South Asia. And we all know that these three gases, including carbon dioxide, methane, and nitrous oxide, are the major contributors to the glasshouse effect on climate, causing heat conditions and creating climate disturbance and drought conditions. All of this situation that made us happen to under these conditions is mostly anthropological, meaning that human activity on climate change is currently unequivocal, and all scientists agree on this issue. If I try to summarize the current situations and also the projections, it is true now that the map of drylands show that 41% of Earth is a dryland area, and this dryland acreage is projected to expand by 11 to 23% by the end of this century. And climate change and anthropogenic activities are worsening as we speak, and the fragility of the cultivated land is increasing, and the agricultural land is becoming more and more hostile to major crops like wheat, maize, and rice. And it is projected that by 2030, global food demand will rise by 1.3% annually, and the cereal consumption will be increasing from 2.7 to 3 billion metric tons. This meaning that there's a discrepancy between the demand in food and the food that can be offered given the cultivation area and the climate conditions that is affecting the productivity of our land. So if I can try to summarize the challenges that are now happening in the dryland, they can be summarized in 3 points. The first one is there is increased food insecurity, meaning that more people increasingly are not really knowing where tomorrow they will find food from. And the second point is the degraded ecosystems that are unable to support traditional agricultural systems. And this degradation is mostly due to intensive agriculture that is not sustainable, meaning that we are using more external input, and this external input requires more environmental load, and then more environmental load is meaning it does not just translate into degradation. And the third point summarizing challenges right now is the rising susceptibility to violence and conflict. To explain this, I can say that, for example, when the resources are dwindling, it is known that social insecurity will increase because everyone will be fighting just to feed himself. So let me walk you through again in the background of the perenniality, as these topics about perenniality. I will try to list the objective of several breeding programs and try to compare this to smallholder farmers' needs and objectives. As you know, several breeding programs are aiming at enhancing crop productivity and adaptation traits. For example, breeding for disease resistance or breeding for drought and heat resistance. And in most cases, breeding programs have reduced the number of functions, and most breeding programs are focusing on annual crops if we put aside the orchard, for example. On the other hand, the smallholder farmers, they have multiple objectives because they have to feed family and to diversify the production. And we can see that for them, the production involves mostly mixed farming systems, including crops and livestock. And the yield stability is also a key objective for the farmer. And they really hate very much the situation that would lead to losses, because if there is a loss, it is difficult to feed the family. And they don't have mostly, if we consider smallholder farmers, they don't have too higher amount of investment, but they have a small investment. But even if it is small investment, they want reasonable returns. And then this leads us to think that focusing on a perennial and a mixed perennial annual crops can be helpful for the smallholder farmers. So if I try to summarize the characteristics of perennial crops versus annual crop, I can say that perennial crops mostly show root biomass seed. They are mostly focused in terms of where we invest energy and productivity. And perennial crops, they have usually low initial establishment, but once they are established, they are there to stay. They usually show low yield at any given season, but when you sum up across the season, productivity can increase significantly beyond what annual crop can produce. The root is mostly deep, and they are not more vulnerable to climate with respect to annual crop. And across our survey, we see that there is a greater soil stability and soil organic matter buildup when we practice a perennial crop with respect to relative to annual crops. You can see on the left panel here, these are the roots from the perennial crops, while on the right panel, these are the roots from annual sorghum. For example, you can see that annual sorghum has mostly a fibrous root, while the perennial sorghum has mostly adventitious root that will stay even under a temperate climate. These adventitious roots that are mostly rhizome will overwinter, allowing the second, third, even more crops without any resowing. This is a cycle. I compare the cycle of annual crop compared to perennial crop. You can see that in annual crop, we plant the seed, and there will be a vegetative growth and then reproductive growth. Once we harvest the seed, the plant is dead. However, for the perennial crops, regardless of which type, because here I try to compare monocarpic, polycarpic, and also a perennial sorghum surviving due to rhizomes. In both of these cases, particularly polycarpic and rhizomatous plants, they will be seeding, and then once you seed, once you plant, the vegetative growth will happen, and they will harvest. And then once you cut above ground biomass, the below ground organs will stay alive, so that when the conditions are optimum, they will emit the ramette, and or they will start vegetative growth from the meristems, and the vegetative growth will continue, and you will be getting reproductive stage and the harvest, and this cycle can continue for 1 to 2 years for monocarpic, for several years for polycarpic and rhizomatous plants. So in terms of if I compare us, Asia and Africa, what we can expect, there will be several areas of research and perennial crop development. Particularly now we are focusing on cereals like sorghum, for example. There will be also legumes, perennial legumes, like pigeon pea, for example. And the co-design that is site-specific, meaning that in any given region, we have to discuss with the stakeholders about their need, whether they need cereals or mixed cropping with between cereals and legumes. Legumes, as you know, they can fix atmospheric nitrogen, meaning that they can bring nitrogen to perennial cereals, allowing the farmer to reduce the external input and then minimizing the cost of production and hence increasing the income. So now let me tell you where we are here at ICRISAT. ICRISAT is now really at the forefront of our perennial arable crop development. As I told you during the premise, we are advanced particularly in the perennial sorghum, as I will show you the results. We have a good population of perennial sorghum that was developed by cross between sorghum bicolor, which is annual, and sorghum harapense, which is perennial. And this progeny, more than 400 entries, are already available and can be shared with partners. And we have, for example, in this slide, I can show you the results from genotyping by sequencing SNP markers that were used to genotype this population. We have observed that in terms of structure, I mean genetic diversity, the perennial sorghum that is derived from the cross I told you between bicolor and harapense, this perennial sorghum is genetically diverse from sorghum bicolor, as you can see in the right side and the left side of this slide. In addition, we have tried to study the ploidy of this progeny from this cross, and we observed that most of the population are tetraploid. As you remember, sorghum bicolor is diploid, while sorghum harapense is the tetraploid. So the progeny is mostly tetraploid, but we have observed some minor ploidy, some of them being tetraploid, but tetraploid will be an imbalanced chromosome number, meaning that this will not be able to set seed, and ultimately when you plant them, they will not be setting seed, and then you cannot continue. They are discontinued. So meaning that most of them in the progeny we have that are surviving winters and that are perennial, these are generally tetraploid. If I can conclude in this, the first conclusion upon what I have just tried to describe to you, as expected, the cross between bicolor and harapense resulted in lines, particularly tetraploid lines. And the GBS data confirmed the distinction between the progeny from the cross bicolor and harapense relative to bicolor, meaning that the perennial sorghum that we developed retained the entire set of chromosome across generations. And as I was telling you, tetraploids are overwhelmingly representing the progeny, but some minor ploidy were also observed. And these minor ploidy, as I told you, they were triploid, but there were some other aneuploidy situations, as I told you, and these aneuploidy situations reflect or imply the possible meiotic anomalies. This is just some pictures I show you to show that our results, our presentation here is presenting empirical data. You can see on the left side. In the left side, this is a perennial sorghum, but on the leftmost side, you can see maize. And this slide on the left is from Italy, where I come from, and this is one of my research stations there. And the right side is here in India, at ICRISAT headquarters, and these are the same set of perennial sorghum I'm just showing you. And I will tell you that these populations, in addition to GBS sequencing and genotyping, we have also resequenced this population with several terabytes of data. And we have observed that these perennial lines, they have accumulated more variants and mutations that are with powerful effect on genetic differentiations. And these mutations are a good resource for sorghum breeding. We have identified around 5,548 genes private to the perennial lines that were mapped to biological processes, gene ontology enrichment terms. Our data also show that the perennial sorghum we developed are mostly taller compared to annual sorghum, and they are early also compared to annual sorghum. And these results were observed both under drought and under irrigation situations. We have also observed that in the perennial sorghum, we have less chlorophyll concentration compared to annual sorghum. And the implication is that in the perennial sorghum, there will be a reduced absorption of excess light. And with this reduced absorption of excess light will result in increased light distribution in the canopy and resulting in a better canopy photosynthesis and ultimately better yield in the perennial sorghum. We have also observed that the dry mass fraction of fresh material is increased significantly higher in the perennial sorghum under irrigation and under drought, meaning that in terms of logistics, perennial sorghum present a more advantage in terms of logistics, because when you park a truck, for example, you will be parking the dry mass, not moisture, meaning that it is advantageous in terms of what you are carrying. You are not burning the fuel only for the moisture, because moisture will not be used, for example, for bioenergy conversion. We have particularly interestingly here also identified dual purpose perennial sorghum, meaning that this dual purpose perennial sorghum can be used both for grain and primary productivity, particularly the biomass, even if at the moment the quality of the grain is not good, but is not a food grade. But this grain can be used for animal husbandry, for example. But we still are working on this issue, and with more of funding, we are hopeful we can produce perennial sorghum with not only biomass production, but also food grade grain production. We also try to investigate the resource use efficiency in these materials. But before I can present the resource use efficiency, this slide is about the biomass yield, the left panel. You can see that biomass yield advantage is clear in perennial sorghum compared to annual sorghum, both under irrigation and under drought stress. And in terms of resource use efficiency, with more focus on nitrogen, we try to investigate the agronomic efficiency of applied nitrogen, and we found that both perennial sorghum and annual sorghum were comparable. However, when we try to investigate the partial factor of productivity of applied nitrogen, which is the measure of nitrogen use efficiency, we came across a neat advantage of perennial sorghum compared to annual sorghum. And we also observed that the perennial sorghum is associated with better reaction norms for primary productivity, meaning that we can have a better production under harsh conditions, and we don't have a negative trade-off when the growth conditions become favorable. So if I try to summarize until now, I can tell you that the whole genome sequencing of this perennial sorghum, we have observed that they accumulated more variants and mutations. with powerful effect on genetic differentiations. And these mutations can be a good resource for cultivar development. And we have observed that single crosses and three-way crosses derived lines from these bicolor and Halepense crosses. They showed interesting agroecological properties, particularly the overwintering, nitrogen use efficiency, favorable norms of reaction, indicating adaptation to low nitrogen without any negative trade-off, being that under drought and or double stress drought and reduced fertilization, we didn't observe any negative trade-off when we grow the perennial sorghum relative to annual sorghum. And perenniality, as you know, it is a sought-after character in sorghum breeding, particularly in terms of animal husbandry, because it can offer multi-culture forage, and also for soil health and several other ecosystem services. For example, perenniality can be associated with reduced soil disturbance and include the soil microbiology. We have observed dual purpose sorghum with the possibility of producing above ground dry mass of around more than 40 tons per hectare, and seed production that can be up to 11 tons per hectare in elite perennial progeny. And we have observed that sorghum Halepense can confer earliness, and as you know, earliness is a very good trait, particularly in the drylands, because it confer the drought escape. That is, it does it when you have a drought escape, then you have a good material for that can escape terminal drought under the dryland situation, for example. And the Halepense, which is the wild crop sorghum species, confers plasticity without negative trade-off, meaning that you can produce more under harsh conditions and even more under better conditions, meaning that this is the crop stability that the smallholder farmers in the dryland are looking for. So this is a summary of the background and achievement we realized. As I told you, the background is we are having difficult in terms of drought and heat, and projections are not really good. And what we have identified is perennial sorghum can offer good solutions, but any given institution cannot do the job alone. We are looking for partners and investment, particularly to scale up this technology of perenniality and improve some other traits. As I told you, we are still working on, even if we realized a good primary productivity, but we are still working on improving the grain quality so that it can be a food grade. And a good consideration here that is encouraging both for the producer or the grower and for the donors is that the results on the research activities and the results obtained right now, they are showing that on average, the rate of return on sorghum and millet research and development is between 54 and 76%, meaning that it is highly important or sizable, and particularly it is positive. Then if it is positive, there is no way to fear investing into this crop, into this research endeavor, because it is generating large producer and consumer benefit for billions of individuals in the world's dryland. So this is right. Indeed, it is about the greater profitability that is associated with the perennial sorghum and particularly perennial crops, and the possibility for the farmer to have their multiple functions satisfied, because perenniality will cover more function objectives. And then, as a recommendation, is crop breeding is really in a great position to give a greater consideration to perennials and perenniality in the context of increasing climate variability and food nutrition insecurity. So this is the keyword that I can conclude this presentation with. And of course, I will get several questions. And but in addition to those questions, I would like to ask the audience to consider my request about a partnership and resource mobilization in order to work on this issue and scale these results we have obtained, and then help the smallholder farmers in the drylands. Thank you very much.
Thank you so much, sir, for this wonderful lecture. So I'm opening the chat box, and if someone has query, they can like put their queries in the chat box.
It was indeed a very informative session. So yeah, everyone, chat box is open. I'll be passing your question to sir.
If there are questions, please, can you read them aloud so I can respond?
Okay, sir.
Thank you.
So if any participants like want one-to-one conversation with sir, they can unmute themselves.
Everyone is appreciating sir about the presentation. Yes, anyone? Is there any question?
Maybe we can allow a few minutes so they can have a digestion of the presentation, and we can get a few questions and or comments or suggestions.
Sir, we are getting appreciation message in the chat box, like lots of
I
We
messages.
think
have
one
got a
question from
question.
Dr. Mansi Das side. Please read this.
Yes, sir. That she would like to know regarding the genomic stability or instability of hybrids.
Okay, thank you so much for this question. When I told you about this hybrid, it does mean we crossed sorghum haripense and sorghum bicolor using sorghum bicolor as a seed parent, and then we grow the progeny up to F7, F8 until they are homogeneous and fixed, meaning that these are mostly, we can call them recombinant or advanced recombinant inbred lines, not a hybrid in the specific term of hybrid F1. These are advanced recombinant inbred lines that are fixed and that can be used in breeding programs, either to develop open pollinated varieties or inbred varieties, or they can be used in a hybrid combination to produce hybrid F1s. So here we cannot talk about the stability of a hybrid, because we developed a recombinant inbred line that are advanced, more or less fixed, that can be used as for trialing, identifying a superior variety in any given ecology, and they can be used in hybrid combinations to produce hybrid F1s. I hope I responded to the question. So these recombinant bread lines are really stable. And I can tell you, for example, in Italy, we have started working on this in 2014. And 10 years now, we are still working on them. And here in India, we have started working on this in 2021. And the same set also was evaluated in Turkey. And the evaluation in Turkey started in 2019. So they are really stable, and they are adapted both in Europe and in Asia, meaning that they have a very good and interesting plasticity. And anyone willing to test these materials, he can just send me an email and I can respond.
Thank you, sir. Next question, Nandini.
Please suggest some perennial varieties.
Yeah, perennial varieties in sorghum, we have not yet developed perennial varieties, but there are in some crops, I think in wheat, also in wheat here, I think in India we have a perennial variety, and also in rice, I think in China, I remember I have a friend there. They have also perennial rice. So there are increasing efforts in this area of converting annual arable crops into perennial arable crops.
Okay, next question, please.
The next question we have got that in world, which fodder crop is cultivated as fodder?
Can you repeat, please?
In all world, which fodder crop is cultivated as fodder?
Cultivated as a fodder, if I got, I think I'm not hearing you very well, but wait a moment, I can increase the. Okay, I can just in 1 minute or 2 minutes, I can tell you when I discussed with here in India with people in northern India, they told me that we have now limitations, for example, to grow forage sorghum in Rabi and Kharif season, because, for example, in Kharif and Rabi season, we have temperatures that are not allowing people or farmers to have the multi-cut forage, for example. But if we start working or cultivating perennial sorghum because of overwintering and great tolerance to low temperatures, it will be possible to grow a forage sorghum in the Rabi and the Kharif season and have a cut that are more than 2 or 3 or 4 cuts. And we have observed, particularly here in India, that the multi-cut forage sorghum can give a yield nearly 400% compared to a single cut forage sorghum. So what I can say that it is possible to use perennial sorghum as a dedicated forage sorghum on the one hand, and on the second hand, it is possible to grow perennial sorghum as a dual purpose sorghum to harvest the seed and then produce the fodder for as a green or dry forage sorghum. So both options are open and are possible.
Okay, thank you, sir. Next.
Yes, is there any question? Anyone?
I think not now.
Sir, two hands are raised also if they want to ask question directly.
Yes, ma'am. I give them permission. They unmute themselves already. Give the permission. So Dr. Kamlesh, Dr. Murai, if you want to like one-to-one conversation with sir, you can unmute yourself.
I think they don't want to ask. Nandini, please proceed.
Okay, sir. So I would like to take a moment to express my heartfelt gratitude for this insightful session. Indeed, it was truly self-explanatory and packed with valuable information. I think we all have learned so much that is going to help us both personally and professionally. Thank you so much, sir, for sharing your knowledge and guidance, guiding us so effectively. Your efforts and expertise are deeply appreciated. Once again, thank you from entire AgriMeet Foundation team, and we all are looking forward that you will give us support in future activities. So, wishing everyone a continued success. Thank you.
Thank you so much. And
Thank you so much, sir, for acknowledging my request, despite being in Calcutta and delivering lecture, sir. And looking forward your support in the next event or academic activities organized by our organization. And sir, some participants are asking for PPT for making their own notes. If possible, then kindly share with us, sir.
Okay, give me just 1 minute. So I will share.
Okay, sir, no issues. After conclude, you may send, sir, as per your
Okay.
convenience. No worries, sir.
No. What I mean is, I want really to thank you for inviting me and give this lecture, and I will also try to tell the audience that we regularly accept PhD scholars at ICRISAT to work on several topics, particularly in my department, to work on sorghum. I have now 7 PhD scholars, but I can still accept 1 or 2 more PhD scholars this year or early next year. So if there is any of the participants willing to make an adventure into sorghum breeding, particularly this area of perennial sorghum, I am really more than happy to welcome them.
Thank you so much, sir. Thank you.
Thank you.
Okay. All participants can left. Good night, everybody. Again, thank you, sir, for joining.
Thank you.
Good night. Take care, sir, please.
Good night.
Good night.